Maybe this kind of picture has already been appeared for many times from the presentations given by different speakers. The Kubeflow can help us to making deployment of the machine learning workflow on Kubernetes simple, portable, and scalable. From the name, you can tell that at the very beginning, it will do the TensorFlow, and if you already attend the previous session of this room, the TensorFlow and Kubeflow has already been elaborated really detail. Without Kubeflow, if we only have the TensorFlow, we'll have the machine learning job, which is complicated. First, I need to understand that, for example, you have 10 machines and 10 nodes. I need to know their networks, I need to know their resources, and when I submit, I need to submit that which has the PS node and which one is the working node. But for the Kubeflow, it's just like the picture shown on the right-hand side. It can also help us to show the complexity of the environment. For example, in the model survey, as well as in the monitoring, it provides different kind of the plugin tools to show this kind of complexity, so that to help people focus on the key machine learning code. In our presentation today, we use the TensorFlow as our TechM, and each year we'll collect a lot of the traces. The amount is about 700,000 each day. And later, I would like to share with you architecture of our topic. And on the left-hand side, on the blue, it is a Kubernetes cluster, and in the dash box, it is the space. It is namespace. And another one, it has the deployment of the microservice and the Istio. So on each port, there's an on-site card. And on the below, we have the Istio system namespace. We also have the Eager and Elastic namespace, but we don't use the Istio default Eager because it is all in one. And it cannot store a lot of the traces. It cannot support a lot of the parallelization. So that's why we need to introduce a architect which can support a large amount of the parallelization. With the Istio on card, we can collect the trace. The trace will be sent to the Eager collector, and the Eager collector, we use our own data store in the Eager. It supports Cassandra Elasticsearch, and finally we chose the Elasticsearch, and data can in the Elasticsearch after the index, it will be stored in the unfast service. And the main part would be the right-hand side, which is for the machine learning. We have the data preparation, and during this step, the data will be pulled from the ES, and then we'll use the data for flattening. Because when we collect these kinds of traces, they can be varied in different layers. So that's why we prepare some data here, and we only select the field that we pay attention to, and then generate a document and put it into the service. And all this kind of the file will be consumed by the Kubeflow and train their own model after iteration. The model will be stored in the object storage. And after that, the model will be served by the Kubeflow and run on the Kubernetes cluster. And this is the overview of the architecture. And now I would like to give the floor to my co-worker, Mr. Zhang Wentao. And thank you, Ms. Yang. And later, I would like to share with you the machine learning in our case. And just now, I just introduced that in the trace there are a lot of information. Among them, there are some data behavior duration and some others. Like that in each trace, we know that which service name it is from and where it goes to. The source, the origin, and the destination's IP address and service code, etc. All these can be stored in the trace. and can be reflected in the service mesh, and then we'll know that how healthy the microservice is. How can we use these data efficiently and to dig the patterns we want? And just now, we just told you that the data is the time sequential one. To be simple, we just select the duration as the target of the machine learning. So let's have a look at the first step. The first step is EDA. In EDA, it is a concept on the statistic or the data digging, which means that in order to process the data, you need to perceive the data. And you know that the features of the data in different degrees and different dimensions. After we have a perception of the data, we can decide what kind of the model we choose to process that. In this example, we use the service duration as the object of the data process, and we can observe it from different time range and time frame, because in different time frame we can see that the features the data show are quite different. So let's have a look at the picture here, the diagram here. So each frame lasts for about 30 minutes, and we can see that within the life cycle of the 30 minutes, the duration fluctuates back and forth. So the requesting time is fluctuating. And in this way, we can know that it is related to the total of the request. We don't need to analyze that what are the costs of the fluctuation. And let's have a look at another dimension, the last 12 hours. So let's see the change of the last 12 hours. The feature has already been flattened, which means that within the range of the 30 minutes, the fluctuation of the duration is really violent. But when we expand the range to 12 hours, it still fluctuates and also shows its features, just like the EDR. But the fluctuation is not violent as before.
If we further magnify the time frame in the last 7 days, starting from June 14th to June 20th, within the last 7 days, you see the characteristics are less obvious. But after June 17th, there was an abrupt change. The time duration increased significantly. And the last diagram indicates total requests in the last 7 days. We can see that there is periodic fluctuation in this diagram. What is the reasons behind? Because the request, there may be different requests in daytime and night. For example, during the daytime, the workload is bigger and there are more requests. And at night, there are fewer requests. So we see the trend here. So now we have initial perception of data for machine learning. Then we are going to process the data with models. As I said, the duration is a time serial data, so we're going to pick a model suitable for time series treatment. So here we use LSTM because, first of all, LSTM is based on traditional RN. This RM can share or transmit characteristics time-wise. For example, there is periodic fluctuation. This fluctuation can be transmitted then the network can learn this characteristic. This traditional RN has its own challenge. Due to its fracture, there may be the layers may disappear. Then ISDM can come to play because it has 3 units for control. It will help us to decide whether this feature should be carried forward or neglected. Therefore, we use LSTM to deal with this data. Just like LSTM to process language. First, we will use model to generate new sequence based on existing samples. For example, when I deal with the time language, I'm here to maybe to speak. So for us, in our case, based on the previous sample, then we will predict the upcoming duration. This is the result of our model training. On the left is the dataset. It's the training dataset, and on the top right is the simulation of the model, and the bottom right is a diagram to verify our training model. So here's the question. In our case here, in terms of tracing, the machine learning uses tracing for abnormality detection. That means through the time sequence prediction, based on the previous time sequence, I can generate the future time sequence, and I will use this estimated. I will compare this estimated sequence with the previous one, and if there is a tolerance and aviation, then I can tell whether this is an anomaly or not. So on the bottom right, we have 990 data points in the test data set, which is indicated on this diagram, and there are 196 data points which are anomaly. So, which is indicated in the red point. So how can we tell whether it is anomaly or not? So we have used some specific algorithm, and also based on our experience. So on this slide, I want to show you that when it comes to data observation, if we use different time frames, then the features or characteristics are different. The value is the same, the number is the same, but the characteristics displayed are different. It's like an old story in China, four blind people touch the elephant. When they reach the elephant's leg, they say it's a pipe, and when they touch the elephant's body, it says it's a wall. So what is the elephant? Actually, the elephant has is a more abstract idea. So we are trying to get these abstract ideas. In order to do so, we need to observe this objective in the big picture. In the bigger picture, this is the same to our model. Let's go back to this slide. If we view the data in a short time frame, you will see huge fluctuation in duration, which is unacceptable, which will be defined as anomaly. But if we extend the time frame, the fluctuation is still there. However, it looks less abrupt then the model will define it as a normal phenomenon because it has been trained for a while and it can learn and master these time characteristics. So for us, we want the model to capture this anomaly in short duration. On the other hand, we also hope this model won't mistreat anomaly as a normal phenomenon.
我们在训练出来的模型，我们不能说训练出来一个模型就放在那里就好了。所以我们
after we train the model,
训练模型的目的是要
we can't just put it aside. The purpose is to serve. So we can release the model as an API, then the applications can use this model. For example, in this case, after we release the model, so this case use 10 points as a time reference, and we can use this 10 point to estimate the future time sequence or time window, and we can estimate its duration. In terms of time is prediction, there may be two approaches. One is a precise approach. For example, I use the real-time duration to do the estimation. Another relies on complete sequence. For example, I will estimate a future time sequence based on the previous sequence. So the first approach is more accurate, and the sequence-based approach may be less accurate. However, if you don't need to have this minute-by-minute real-time accuracy then for estimation. If you just want to know the possible trend, then the time sequence-based approach would be better. Okay, coming back to our topic here. So what do we want to do? First, we want to test anomaly. When I use 30 minutes or 1 hour data as a sample, if I use this as the data input, then I will get a small time frame model, which we call it model 1. With this model, I can estimate what happens in the last 30 minutes and is there any abnormals over the last 30 minutes. But we can also extend the time frame, then we will get a bigger model. This model will help us to identify the characteristics of a long period or long duration. It will help us to scale it. For example, in the previous instance, there is a peak or a change, abrupt change over the last 7 days. That would indicate that the total request may reach a peak. As a result, the duration show frequent anomaly. If we can use the model to predict that over the long duration, there may be some abnormal characteristics, then we can use some auto-scaling mechanism. For example, take ingress as an example. There is a long delay, then we can use its metric. And in the premise, we can get the memory usage of ingress. And if these two characteristics are consistent with the data collected in the duration here, then the duration increase suddenly, I can scale it horizontally. That will help to expand its business capability. And after this duration peak, the request decline. Then we can scale the ingress down in order to save resources. And in terms of model training and deployment, we use the cron job in Kubernetes to train it regularly. Because with a bigger time frame, we need more data set that would require longer training. But for a small model like 30-minute model, the data itself is small. So the training can be shorter. That means we can iterate the model quickly and launch it. So in our example here, we use the Istio. Istio help us to do publishing in different versions easily. So that's our presentation. It's about collect the traces in Jaeger and do the Kubeflow and do the model and to identify the anomalies in our microservices. And after the anomaly is detected, we can notify the operation team for intervention. And also help them to do some auto-scaling so that the microservices can provide more service. So this is what we want to share. If you have any questions, you can raise your hand. Please use the microphone. So when you do the anomaly detection, I get your question. So you mentioned about the classification and recurrence. So here in this time frame, it fluctuates. It keeps coming back and forth. If I just use the long-term model, it will treat this value as normal because it predicts the characteristics will happen here, and after it learned it, it will treat it as a normal phenomenon. In this case, I will use the cluster algorithm to identify the points, abnormal points. My second question is that for those abnormal points, when you detect it or before it, why don't you use some engineer work to identify it? Have you ever tried to use some traditional machine learning or like characteristic engineering to identify the characteristic first? Wouldn't that be better? Maybe. We will think about that. We will give it a try. Third question is that going forward, will you use this together with the scheduler? Yes. Because this will involve the distributed model training for bigger version and dimension, the single pod or single job to train the data. This can be problematic. Therefore, we have a lot of jobs submitted. Then we, of course, want to use a distributed approach. The traditional scheduler face some challenges when it comes to parallelizing, but later we'll think about use a KubeEdge as a scheduler.
My purpose of asking this question is that if you try I would like to know that for the schedule and the others, which one will affect the usability? So when we deploy, it needs time, and the time cannot be fixed. It depends on the time and the network. But for the schedule, I hope that I can use it as soon as possible, right? So it requires the good performance. So I would like to know that is there any imbalance between these two, so that it cannot be used. So when you deploy the model, can you still use the TF survey and another kind of the model of the optimization method? Well, so far we haven't encountered this kind of the problems so far. All right, thank you. I have a question. And how can I ensure that what I train is the one I would like to use in practice? Well, in other words, do you think that the training is only available in can be in one area, or it is in common? Well, actually, what we train, it is the best service. You can understand it in the relative field. Okay, so after I train it, I can only use it in one service, right? Yes, that's right. It is not a common model. And in the final, it will have the auto scaling, right? Yes. So I would like to know the time of the auto scaling, and I would like to know that when it is decided to scale up and when it will decide to scale down, and what are the criteria. Or if I would like to scale it up, but the process is really small, it is really slow. For example, and actually I need the 80 requests, but actually I can only support 50 requests. But if it scale up from 50 to 80 and it will fail in the 52, and what would happen and what would you like to do? Well, actually in our case, we don't have such a large amount of requests. Yes, these kind of the problems may happen, but we won't scale from the extreme like as you described. Well, actually, is there any possibility that when you do the auto scaling, there are some oscillation? Yes, the oscillation can be happen. So how can you ensure that this kind of the oscillation can be avoided? Well, actually, for this kind of the oscillation, when I scale up, and the number will be increased. So the process ability will be increased. In this way, the duration will be reduced, right? Yes, that's right. So that's why we have to use at least two models. And for the auto scaling, I use it for the long-term model. So in this way, I can avoid that it will notice the violent fluctuation. And then it would fail. What does that mean? I don't know. So another model is responsible for judging, not the same service, right? No. So this one is for compensation, right? Yes, and this one is for compensation. All right, due to the time limitation, thank you very much for your attention. And if you still have any questions, please welcome to talk to us later.